this 10 minutes break, don't worry. After, in about 50 minutes, we will have a 1 hour break, okay? So you can have lunch or relax or rest a little bit, all right? So this module is the web application insecurity module, is focused on basically all the attacks, or most of the attacks that we can perform against web applications. Okay, now we have already discussed the problem with HTTP. We will see that there are more and more problems that we have with web applications. All right. Now, normally when you are attacking an entity, you are going to basically you're going to learn how this entity works. In terms of web applications, you're going to learn how the web application works. You're going to learn how the environment of the web application is actually created. You're going to see if there are 2 tiers, 3 tiers, if we have an authentication server, if you have a database, what kind of database, what kind of web application technology we have, what kind of, for example, operating system the web application server, the web server uses. Okay, so essentially, we're going to, if somebody wants to attack a web application, the first thing that it's going to do is reconnaissance. Okay, so try to get more information as possible. Then we are going to see how web application can be attacked, and then we will discuss general concepts regarding web application firewalls. Okay, now reconnaissance. As I said before, reconnaissance will basically gather information regarding your web application. What kind of information do we have? We have lots of web information about your web applications. We can use DNS servers, for example, okay, to get the information about your domain, about the servers that are behind your domain. We got information that are delivered by the web application itself, like remember when we open, and let's actually switch to the live session. Remember that we created this query, we forged this get request to the bad store to our web application, and then what the server did was replying with a server header saying that this is Apache 1.3.28 with module SSL 2.8.15 enabled, and it is using OpenSSL 0.9.7c as library. Okay, so this is basically free information that our web server is giving to us. Okay, during the reconnaissance phase, people that would like to perform an attack will actually gather all this type of information. Now, there are also some open source databases that we can actually use. We can consult the Google hacking database. We can use social networking websites. Okay, we can use Facebook, LinkedIn, and so on to get, for example, who is the network administrator of your company. All right, we can trick people by giving information to people who are not authorized to receive this kind of information. Okay, so the reconnaissance aspect is actually a very, very, very vast, let's say, topic. What we are going to focus in this course is the tools that we have in order to perform reconnaissance with our web applications. These tools, by the way, are the same tools that are used by, for example, network admins. Okay, for example, let's take the first one, Wireshark. I mean, you can download and install Wireshark in your computer, and you can use this tool to analyze your network traffic because maybe you have a problem. Or you can do the same to analyze the conversation between your client and a web application to get more information about that web application. You see here, this is the follow TCP stream function of Wireshark, and what you see here is basically that the server header is included, okay, as we've seen when we have forged this request. So essentially, Wireshark will allow you to capture traffic, capture packets, and then analyze these packets. You can also save your the packet stream, okay, so you can process it later. And this is interesting, for example, for encrypted traffic. Now, if you don't want to use Wireshark, for example, you can use your browser. I mean, that's the client. You can install add-ons into your browser so you can manipulate or you can see all the requests that your browser is doing and all the responses that your browser is receiving. All right. Now, popular plugins are, for example, temper data, live HTTP headers, and so on. These plugins are installed in your browser, and then you can basically see and say, oh, look at that. That's a cookie. What's inside that cookie? Let's see what's inside that cookie. Then you can analyze the content of the cookie. All right. Normally, you don't see this. Okay. Normally, when you interact with a web application, like we were doing with our pet store. Let's actually move this window up. Sorry. One sec. Which is, by the way, the web application that we're going to use in our lab. You don't see it. I mean, I click what's new, and then I don't see the request. I don't see the response. I just see basically what the browser is presenting me. By using browser plugins, we can see behind the scenes what is happening behind the scenes. Now, we can also use some intercepting proxies. Okay. Now, the term proxy, if you're familiar with this term, normally is used by identifying specific devices that are used to intercept internet traffic, filter this internet traffic in order to protect companies from, I don't know, accessing a specific website that delivers malwares and so on, all right? Or to enforce some company policies. Now, those are called web proxies, okay? And these are these devices that will filter internet connections. Proxies in our environment, in the web application world, are software that you can install somewhere. It could be your computer, it could be a dedicated computer, that will basically allow you to intercept any request and any response. And proxies will also allow you to tamper with the response and with the request. So basically, it's like a man-in-the-middle attack. And in this case, you are the man, okay? You are doing it on purpose. So you are sitting between the browser and the web server, analyzing everything and saying, oh, look at that, that is interesting. That is, oh, you can change this, you can modify this. Now, there are several intercepting proxies that you can use when you're doing web application analysis and reconnaissance and so on. The two ones that are displayed on this slide are ZAP, which is this like flash symbol, and then we have burp. Okay. Now both can be downloaded and used freely. Burp has another version, has two versions: the free version and the professional version. The professional version has more, let's say, more functionalities. Okay, some limitations. The free version has some limits, like rate limits and so on. The professional version costs some money, but if you are a web application pen tester, it might be worth to use it. Okay. Now, for our lab environment and for the examples that I will show you, I will use ZAP. Now, how do we use intercepting proxies? We basically installed it in our system. This is ZAP, okay, installed in my computer. In order to basically point to this proxy, I would just need to change the proxy setting of my browser. Okay, in this case, ZAP, if I go to the options and I go to local proxy, you see that ZAP's listen on localhost port 8080. So if I change, let's see if I have something here. No, this is the request that I did before. If I change my browser settings, I go to options, and then network settings, and then manual configuration for 127.0.0.1 port 8080. Okay, so this is now Firefox configured to go through ZAP. I'm going to click on the home page, and what is happening is that the request is actually tracked down into Zap. Okay, these are all the requests that my browser had done, and I can actually see the request and the response. Okay, as you can see, for example, in the request, we have a referrer here, another type of agent. We can see all the headers that our browser have automatically used, and also in the response, we have information, okay, about, for example, what is the cart contains 0 items or $0. Okay, this is what it's displayed basically here. Okay, so we can really analyze anything that is going between our browser and our proxy. And our web server. We will use proxies to temper traffic, okay, between web browsers and web servers, and you will see that bad things can happen when you start to tamper with web applications. Then we have scanners. Scanners are automated tools that are used to attempt to find vulnerabilities. Okay, you basically use a scanner, you point the scanner to a web application, and then the scanner will basically crawl the web application, test the web application, and then it say, oh yes, this web application does not process very well this type of characters, or if you inject this string, bad things will happen. And if you want, scanners can automatically exploit these vulnerabilities. Okay, so the scanner can be configured to automatically hack the web application. Okay, again, Zap is also a scanner. It is a proxy, but it is also a scanner. If we go to Quick Start, you see here, welcome to Zap OS attack proxy. URL to attack. You just put here the bad store URL. You click attack, and then you will see what are the vulnerabilities of the bad store. Actually, let's do it. badstore0.q.u q.u.org, and let's click attack. And as you can see, the system is actually crawling the web application, getting all the information about the web application. And then if we go to the alerts, we see, for example, some alerts. Okay, the cookie is set without HTTP only flag. Okay, this means that the content of the cookie can be accessed by client-side scripts. This might be wanted, or it might be a problem. All right. So this is essentially a scanner. What the scanner will actually do. In this case, it didn't exploit the web application. It just scanned the web application. Now, another thing that we can do is using another tool that it's called fuzzers. Now, fuzzers are essentially specific tools that will allow you to specify some data, which can be random data, or it can be a preset of data, and then you can send this data to the web application. Okay, this will allow you to basically see how the web application handle exceptions. Okay, what are exceptions? Exceptions are something that the web application didn't expect, okay, to happen, but it did happen. And if the web developer is smart, it will catch the exception and then, for example, present an error page saying, sorry, something went wrong. We'll deal with it. Okay. If the web developer is not smart, what you will see is an error. Okay, and errors are one of the worst things that can happen in web applications, because generally errors give away information for free. Okay, for example, in this web application, our web store, in that store, we can search for items. Okay, we can search for 1,000, for example. But what about if we search for ABC? Oh, that's an error. Okay, so in this case, you see here, this is the query that our web application is using is actually pasted in the page. Another error could be if we use, for example, some specific characters, like a single quote. All right, we'll discuss this in a moment. Look at that, software error. We can get information about the database. This is a MySQL database. We can get information about where the web application is stored in the application server. What is the line of code that triggered this exception? All right, this is what phasers will actually do. Okay, there is a question: can we consider using phasers as DOS attack, denial of service attack? Actually, you could crash a web application using a phaser, but this is not why we have phasers. We have phasers to test the web application in order to see how it reacts. Okay, if it crashes and this is what you want, that's a denial of service attack. Good for you. But normally you use phasers, for example, to if you have an input field like this, okay, you can point your phaser here and you can say, please test all the numbers, all the letters, and see what happens. Okay, so if the system was testing numbers, everything was fine. Then it started to test letters. Oh, look at that. That is a problem. There is a bug. Okay, because this shouldn't happen in the web application. So this is how you use phasers. Or you use phasers in the username and password fields. Okay, when you have to do brute force attacks, you point the phaser in the username part, in the password field, you feed the phaser with some files like usernames files and password files, something that you can find easily on the internet, and basically the phaser will start to try username and password until it will find maybe one is valid. Okay. Honestly, it is very, very difficult to overwhelm a server with a single client if the request is processed correctly. If the request is not processed correctly, that's another story. And we will discuss about denial of service attacks. Okay. But this is not a denial of service attack per se, but it might generate a denial of service attack. Okay. No, it's different than the distributed denial of service. You could crash a web server with just one client. You can do that. Okay. Just performing a denial of service attack. You can do that. You don't need to have a distributed network. But you can also do it with phasers if the application crashes. And we will discuss about this. All right. Don't worry, we will get there. So these are the tools that we have to analyze the behavior of web application, how it reacts, vulnerabilities, it can be exploited. It will exploit the vulnerabilities for the scanners. We can use Wireshark to get information, add-ons, and so on. Once we have collected all this information, normally what you have to do is take pen and paper and start drawing a diagram. Okay, you start to draw and you say, okay, this is a web server. The web server is Apache. We said, okay, we have an operating system behind the web server, of course. Then the web server operating system is, for example, Microsoft's Windows Server, whatever, or Linux or Unix or whatever. We got information about the network, okay, of the web server. So we are starting to draw a diagram. Everything that we have collected has to be put together in this diagram. We have the language of the web application, maybe versions of that language, of the processor of the web application, and so on. Okay, if there is a database, an application server, and so on. So we are going to create a map. We can do this manually, or we can use spiders. Spiders are essentially dedicated tools that will allow you to crawl the web application, gather all the information for you, create a map of the web application resource. For example, like our Zap did. Okay, if you take a look on the left side, we have information about all the directories, the pages. This is a JavaScript that was downloaded by Zap. So essentially, it has created like a structure of the web application. Of course, we don't have all the information here. We also have some information about, for example, procedures, uploads, files. We have an XML file here. So we can get a lot of information with spiders. Okay, so normally an attacker would use a combination of manual reconnaissance and automated reconnaissance. Okay, the manual one is the preferred one, but is the slowest one. Automated one is the fastest one, but it can, let's say, be detected, okay, by some IDS systems, for example, and sometimes it will generate a lot of false positives. So whoever is analyzing your web application might use both systems at the same time. Okay. Now, there is actually a point in time where web applications were very widely used, and they became the target of hackers, attackers, and so on. Now, the problem with web application is that you don't really know who is using your web application, and you don't really know that the web application is used in the way that you designed the web application. Okay? So for example, here we have two users. We have Tommy and Lucas. Now, from a web application point of view, these are normal users. Okay, they are generating HTTP requests. The web server, the web application is generating HTTP responses. So no differences between these two users. The problem is that Lucas, in reality, is not Lucas. His name is Heisenberg. And inside this HTTP traffic, it is injecting some code. Okay, this could be an attack, this could be anything. Now, from a web application point of view, the web application is not able to differentiate between Lucas, Heisenberg, and Tommy. They are the same. They are users. And if Heisenberg is using the web application in a way that it's not designed, then in that case, it is a problem, okay? Because the web application might generate exceptions and so on. Is my audio okay? Because I'm checking the audio and everything seems to be fine. All right. Okay. So there is an entity, an organization that is called OWASP. That stands for Open Web Application Security Project, that every 3 years creates a list of the top 10 attacks that were performed against web applications. Okay. Now, this is an independent organization made of different people from different companies, and the way that they create this list is by considering the damage that a specific attack can have, it can inflict to a system, to a company. It will consider how easy it is to reproduce this specific attack and other factors. So they will then create this list, and they will basically categorize all these attacks based on the requirements, like if it is easy, not easy, if it is reproducible or not, and what is the extension of the damage. Now we will analyze these attacks, okay, one by one. I know this is a lot of information to take in, but again, this course should be used in this case with the introduction just as a starting point. If you are never seen anything like a SQL injection, this is going to be the day that maybe you're going to take a book and read about SQL injections. Okay, I will explain what they are, but there are much more. Okay, we can talk about SQL injections for half a day, even more. Okay, so again, we're going to discuss these attacks. I'm going to explain to you these attacks because these is necessary for the WAF configuration, not because I have to give you the knowledge how the SQL injection works. This is nice to have, of course, I will give you the knowledge, but this is nice, this is actually mandatory for the WAF, because the WAF will tell you, all right, do you want to be protected against cross-site scripting attacks? Now, if you don't know what is a cross-site scripting attack, how can you configure, can you tell the WAF yes or no? How can you check that checkbox? Okay, mark that checkbox. All right, so we will again start with the first attack, which is the injection attack. Okay, and then we will cover all of them. Now, the injection attack will basically allow an attacker to create a specific payload, so to craft a packet. Let's call it a packet. It's not really a packet, but let's call it a packet, and inject this packet to specific interpreters through the web application. So we are going to use the web application to then inject our code to, for example, the operating system. We're going to inject the code to a database. We're going to inject the code to an LDAP server. Oh, the dear LDAP server that all system administrators care a lot about. Okay. We can also inject code in the logs. We can inject JavaScript into the web application and so on. So we're going to basically create a piece of code and then inject this piece of code to different, so that it is interpreted by different interpreters. Okay. Now, in case of databases, if you're injecting the code into a database, this is called a SQL injection. Why SQL injection? Because SQL is the name of the language that we're going to use to interact with databases, and injection because this is a type of an injection attack. Okay, so we have here our web application that we have used before for the movies, right? And we have a title, year, and price. But this time, instead of Tommy, Eisenberg is using this web application through his browser. He's not using any kind of a specific tool to do this attack, although there are tools available for SQL injection attacks. So this is what is happening, basically. Let me get my laser pointer. In the title, Eisenberg, instead of putting the matrix, for example, he is putting A. Okay, this is random data. It could be the matrix, the Godfather, ABCD, 1, 2, 3, 4. It could be anything. All right. Then he's going to use a single quote. Okay, and then he's going to put or 1 equals 1, and then click submit. Now, this is going to be sent to the web application. The web application will then use this code and put it into the SQL query. Remember, this is exactly the SQL query that we've seen before in the introduction to, in the overview of web apps. So select anything from the movies table where the title equals A, that again could be the matrix, the Godfather, whatever. And then we have this single quote. This single quote is an escape characters. It means for a database, from now on, try to execute the code that you will see on the right side. All right. So in this case, we have A or true. So select everything from movies where A, the title equals A or true, because 1 is always equal to 1. All right. So what is going to happen is that the database will then process this query, and it would say, I want to actually search for a movie. It's called A, but I don't have A. Oh, look at that! But I have to evaluate that code. When 1 equals 1, always. All right, there you go. Boom, dump. This is the dump of the database. The dump of the database is going to be sent to the web application. The web application will then send the dump to Eisenberg. What can we have inside this dump? anything that you want. You can have username and passwords. You can have credit card numbers. You can have the content of a specific page that is generated by the web application. You can get whatever you want, okay, by just using this type of injection commands. All right, let's see a live example. Let's go to our website, the pet store, and let's search for the item 1000. Okay, item 1000 exists. Now, let's take a look at the table that we have here in the new items. We have item number 1000, 1003, 5, 8, 9, and we have the item with the description. All right. Now, as you can see here, some items are missing. 1000, 1003, so 1 and 2 are missing. 4 is missing. 6 and 7 are missing. All right. Now, if these items are missing, it doesn't mean that they're not there. Okay, it might be that they are not there, but we can do an educated guess and we can say that the web application is presenting us this kind of data because this is the data that is configured to be retrieved by the database. What happened if we change the logic? What happened if we trick the web application so that it can retrieve all the data from the database? Let's do it. All right. So let's use, for example, 1000. I can use everything. I can use actually ASD, but let's use 1000. Okay. Then I will use single quote or 1 equals 1. You could use A equals A. 1000 equals 1000. 2 is bigger than 1. Whatever you want. You have to insert here an expression. Okay. Then, because this is a MySQL database, we have seen the error before, so we have done our homework in the reconnaissance and web application analysis part. I know that I can use 2 dashes and a trailing space. So this means that whatever you have on the right side of your query, so basically this part, don't use it. Comment it out. Okay? So this will prevent that this SQL injection will not be executed correctly. All right? Then I will click search, and voila, we have all the items. Okay? As you can see, that the web application has retrieved 1001, 2, 3, 4, 5, all of them. Okay? And it has presented this data to me. Okay? So this is just an example of what a SQL injection can actually do. Yes, there is a question. Can you explain the double dash again? Now, when I search for the single quote, I saw that the database technology is MySQL. Now, if you read through the MySQL documentation, you will see that to comment something, you can use 2 dashes. Okay? So what I'm going to do is basically I'm going to create my SQL injection query, and then I'm going to say everything else that is on the right side, disregard it. So everything that is written after the last one, disregard it. Okay, this will basically make sure that my query will end here. Okay, my statement will actually end here. Okay, and not somewhere else where I don't know. So this will basically allow me to perform the injection. Okay, if I don't put the 2 dashes, then maybe something will get in the way, and I have an error. Okay, because maybe the structure of the query contains something else, and so it will concatenate all the code and we say, what the hell is this? Okay, that's syntax error, something like that. Is it clear? All right. So these are injection attacks. Okay, SQL injection is one of the most common attacks that you will actually read on the news. Like Sony, first attack was a SQL injection attack. TalkTalk, SQL injection attack. Medidon, what it's called. Well, there was an adult website, I don't remember, Amazon something was a SQL injection attack. Okay, so this is one of the most powerful and let's say most used attack that we have nowadays. Another attack that we can perform is the broken authentication and session management. Now, in this case, we're going to tamper with the session IDs. All right. For example, let's say that we are in Starbucks. We're drinking our coffee and we are trying to book some tickets, okay, because we have to fly somewhere. Now we go to airline.com, login.html. We're going to then log in. We have our session ID, okay, that is generated by the web server, but something is happening. Since we are sharing the same Wi-Fi connection with other guys, there is a guy that is called Heisenberg again, that is sniffing all the wireless traffic, and it is basically seeing all our traffic. Why? Because look at here, we're using HTTP. So this is clear text traffic. So Heisenberg is able to simulate our session. This can be done also with cookies. You are logged in into a website using an unprotected network, okay, like a shared Wi-Fi, and people will basically sniff out your cookies, and then all of a sudden they are logged in at your bank account with your credentials. Hopefully this will not happen, okay, but it could happen. All right. This was the case with Facebook years ago. There was a problem in the logic behind the session management of Facebook. So if you were using an unprotected network, there was actually a plugin that was sniffing cookies around, and basically you will be able to authenticate yourself as another user in Facebook. Okay, this hopefully was corrected with changing the logic a little bit of session management. Another thing that can be a problem is that, let's say that I am logged in into airline.com. And then airline.com says that session ID is 03098301. Now, what happened if I change this URL and I put a 2 at the end? So it's going to be 03098302. Now, if the web application is not designed correctly, I will be logged in as another user, right? This might be a valid session ID. Okay, so this is broken authentication and session management. Another type of attack is the cross-site scripting attack. This is actually an injection attack that has its own category, A3. All right. Now, in this case, we are going to inject code into the web application. And when that code is then retrieved by a user, the user is hacked. So we have Heisenberg here, and Heisenberg is making an HTTP request to this web application. This could be, for example, a forum, or it could be, for example, you buy something on Amazon, and then Amazon asks you to do a review, to give some feedback about this object or the transaction. So you say, oh yes, the object was sent very quickly, and it was okay, and it's nice, and so on. Heisenberg will not write that stuff. It will write script equals whatever. Okay, so it will inject code into the web application. When Tommy wants to retrieve this information, maybe he wants to buy the same item that Heisenberg bought, and he's reading the feedbacks from the other users. In the feedback form, he will actually download the code that Heisenberg have injected in the web application. So the browser, when it's parsing the code, it will then say, oh, look at that. That's a script. Okay, let's execute it. And what the script will do, it will get, for example, the session cookie from Tommy's browser, and will send this session cookie to an external server, like HackerLand. All right? Now, this is actually very easy to perform, all right, unless the web application doesn't have some kind of filtering mechanism to escape some characters. The same is valid for SQL injection, of course. So a typical example of secret cross-site scripting is that you have a guest book, like we have in the bat store. So you can leave a message here. Now, if I leave a message and I can, my name is test, for example, my email address is test@test.com, and the comment is test. All right, I will add this entry, and what it's going to happen is that, wow, this is very bad actually. This is my ZAP scan that left all these empty comments. So I have here my test comments. All right, so as you can see, the browser has shown me this. Okay, it presented me the same content that I wrote in that input field. What if I will basically say that my name is test and my email address is test.com, and then as a comment I put script, and then I will close the script, and then I will say alert, hello. Okay, now instead of writing something in this guestbook, I am actually writing a script in this input field. Okay, what it will happen is that when I will click add entry, this script will be saved into the BetStore web application. So whoever will browse the guestbook will load this script. Okay, what is going to happen? This is stupid pop-up window saying hello. Okay, but this could be anything. This could be the getting a cookie and sending to an external server. This could be honing an entire operating system. There are frameworks that are created around cross-site scripting attacks that will allow you to turn the webcam on, turn the mic on, send files, retrieve files, get information about the operating system, and so on. Okay, this attack is one of the most powerful attacks that you can use nowadays against web applications. Okay, so cross-site scripting. Why cross-site scripting? Because we are going to use a scripting language, JavaScript in this case. Cross-site because we are going to use, we are going to connect actually a web server, a web browser to another site, okay, to another entity. Then we have insecure direct object references. Now, in this case, we are going to be able to access other objects, okay, by tempering the requests and the responses. Pretty much like the session information, but in this case, this could be an account number. Okay, we might be logged into mybank.com, so we have an account in mybank.com, but then we will temper the URL and we say, okay, my account number is 1000. Let's see what happens if I put 1001. Okay, if the web application does not filter my request, in that case, I will be able to see your bank account. As easy as that. Then we have A5, security misconfiguration. This is something that can happen, and it will happen, of course, if you don't maintain your systems properly. For example, you can have older versions, vulnerable versions of the operating system of the web server. Okay, you can have vulnerable libraries like OpenSSL. You can have vulnerable web application technology libraries. Okay, like for example, you're using PHP, using ASP, version that is vulnerable to such specific attacks. The same is for databases. Okay, now there are some ways that you can prevent SQL injections to happen in databases. For example, by using stored procedures. Okay, so procedures that are called by the web application, and the database will execute these procedures without needing the need to write the query in the web application. Okay, this is configuring the database in a certain way. Also, the database must be secured. Okay, in a way, in the configuration, the whole environment actually has to be secured. Okay, so network segmentation and so on. Then we have sensitive data exposure. Sensitive data exposure will basically allow you to retrieve data like credit card numbers, your username and password, and so on. Now, normally, from a security point of view, this kind of data must be encrypted while it is moving so in transport, and while it is at rest. Okay, best practice. Now, that's okay. The problem is that the web application, because the way that it works, has to be able to access this data, right? I mean, if a web application has to do the checkout in Amazon in order to confirm that you're buying, I don't know, a new router for your house, in that case, it has to use your credit card number and then connect to whatever provider is using for that credit card number to actually execute the transaction. This means that the web application somehow will access this information. So even if data is encrypted at rest in the database, then maybe the web application has the key to decrypt this data. So essentially what we are doing here is that we are either using the web application to decrypt the data. So we are basically using the web application technology to say, thank you for these credit card numbers, or we're going to steal the encryption keys, okay, that normally are stored in the application server, all right, unless you have an external module like an HSM. So this is sensitive data exposure. Then we have missing function level access control. Essentially, this will allow you to access some administrative pages of your web application. Normally, this should be forbidden if the system, in this case, the system administrator and the web developers didn't do their job correctly. You might be able to access some portals that you shouldn't access, all right? Or you might be able to access some private parts of your web application where normally you should be authenticated to access those parts. So in this case, the web application is not checking either if you are logged in or not, and if you are logged in, it is not checking your level of authorization. All right, let's do an example. Let's use our pet store. If I search, if I click what's new, you see that URL is petstore00.qw.org, CGI bin, petstore.cgi, question mark, action equals what's new. Let's put admin here. Wow, secret administration menu, right? Now, in this case, we have tampered with the URL, but can we actually execute this? No, we cannot, all right? So in this case, we were able to see that portal, so there was no authentication level between unauthenticated and authenticated users to access that portal. But then if we try to access the functions inside this part of the web application, we are not authorized. Okay, so in this case, we have half of the security. Then we have A8, cross-site request forgery. Cross-site request forgery, I think, is one of the best attack that you can perform against a web application. It is one of the hardest one to accomplish, but if it is done properly, then it is the damage that you're going to do is extensive. All right. Now, cross-site request forgery normally targets users, like cross-site scripting. Okay, you are going to our target is the user through the web application. SQL injection, our target is the web application, or actually the database, okay, through the web application. Cross-site request forgery, cross-site scripting, they will target the users. You are hacking other users through web applications, right? And this is basically how cross-site request forgery works. Let's assume that Tommy is logged in into his bank account, okay, using the mybank.com web application. All right, so mybank.com, login, username and password, that's fine. He's logged in. He has the session cookie for mybank.com. Okay, then Tommy is going to open another tab or another window of the same browser, because maybe he has received an email saying, iPhones, new iPhones at 300 euros. Click here. Okay, so he would click on that link, and then that link will go to hackedwebsite.com. Okay, so this could be a normal web application that has been hacked previously, or this could be a malicious server that is on the internet just to deliver bad payloads. All right. Now, HTTP request will actually start to load, okay, to request the page. Now, if we analyze the source code of this page, we have that, of course, this is welcome.html page. We have HTML. This is the tag, HTML tag. Then we have another tag that is an image tag. But in this case, the image tag it's actually an image source tag that normally will allow a browser to download an image. Okay, you might have that your image is hosted somewhere else. Okay, in another website, in another part, or in another web server, and so on. But in this case, the image source is actually very strange. It's mybank.com. Right, so it is actually the bank website / transfer. Now we have some kind of query here. So essentially, what happened here is that the hacker has pre-forged a query, a request, with all the necessary information to deliver money from one bank account, to transfer money from one bank account to another one. Okay, so we have here the amount is 1,000 euros, pounds, dollars, whatever, and the destination account is 130 whatever. Okay, what is going to happen is that when the web server will create the HTTP response of the welcome.html page, the browser will download the page, it will parse the code, and when it will reach the image source tag, it will say, oh, I need to get that image from that link. So it will create an HTTP request for that image, which is not an image, because that request is actually the bank website. Okay, it's the bank web application. But wait a moment. The browser has the session cookie of mybank.com. So as we said before, the browser will use that cookie because this is how it is programmed. Okay, it will use that cookie. So it will open a connection to mybank.com using the session cookie. So we are authenticated as Tommy, and then the amount of 1,000 is going to be transferred to a destination account. What Tommy will see? Nothing, really. He might see an error in the main page, depending on how it's written in the code. But honestly, this is quite transparent. Now, how many times have you logged in your bank account, and then on the other page you had another window of the same browser open in another website? All of us have done this, right? Okay, it can happen. Problem is that web browsers don't have pure session separation. Even if they all say that every tab is a process and they have a sandbox and they cannot access external part of your web application, of your system, this is all true until we talk about sessions. When we talk about sessions, they all share the same, for example, cookie jar. So if a cookie is inside the cookie jar, that's it. It's going to be used if the domain is the one that is defined in the cookie path and domain. All right. So this is cross-site request forgery. Then we have A9, that is using known vulnerable components. Well, in this case, we use a scanner like Zap. We're going to basically scan the web application, and then if there is a module that is vulnerable, boom, we're going to exploit it. Okay, we can use, of course, automated tools like Burp, Zap, and so on. Yeah, this is the Heisenberg is the attacker. Okay, let's say that you want to see if the campus website is vulnerable. You then use Zap, You point it to campus, and then you scan campus, and then maybe you will find that the main page is vulnerable to second and SQL injections. Okay. Now, in this case, again, these are attacks. All right. Now, don't perform these things on systems that you don't own. It is illegal. In some countries, you can really go into trouble if you do this. All right. So everything that I have explained to you, this is just for educational purposes. Don't point a scanner to campus. Don't point a scanner to Amazon, and so on. You can get in trouble. There is a question. The attacker can then use the cookie and use it to access the bank account. I think this is referred to cross-site request forgery. No, the attacker is not in possession of the cookie. Okay, the attacker knows how the mybank.com web application works. He knows it, and he knows that if he creates a query that looks like this, then money is going to be transferred from one bank account to another one. So it doesn't have the cookie. What is going to happen is that the cookie is inside the browser. And since this session cookie is valid for mybank.com, it is going to be used in this HTTP request, because this is what browsers do. They will check the domain, the path. Is it valid? Yes. Use it. That's it. By default, you cannot prevent this. Okay. Well, you can prevent this. You can just disable cookies in your browser, and that's it. But then you won't be able to log in into the bank web application in the first place. All right. So that's a requirement. The user must be logged in. There's a question is coming up. How the attacker will actually leverage? I mean, what's the benefit for the attacker, and how is the user affected? Basically, the destination account number here is the destination account number of the attacker. Okay, this is the amount of money that we're going to transfer. The source account number is Tommy's account. Okay, so all of a sudden, Tommy will basically say that 1,000 euros will move from his bank account to the attacker's bank account. But essentially, this is a valid transaction. Okay, it's like if Tommy was transferring the money by itself, but it's not. Okay, because this is something that went behind the scenes. Tommy didn't realize this. So the attacker now has 1,000 euros, and Tommy has now 1,000 euros less, and has now 1,000 euros less in his account. This can be done for everything. I mean, I just used the bank example, but this can be done also for, let's say that you have a web application that is used to manage your firewall. All right, your network firewall. Now, I might know how your web application works, and I might know how admin users are created in your network firewall. So by crafting a specific query, I can add a new user, a new admin user. So what is happening is that maybe the network administrator is logged in his network firewall with his browser, and then with another page, again, he's going to browse to my website. As soon as he browsed into my website, this happens. Okay, he is logged in into the network firewall, so he has a session cookie. Then, boom, the request is open to the management interface of the network firewall, and a new user is added. Easy as that. Okay, so this is not only valid for banks, it's valid for any kind of web applications. Another question is coming. Just waiting until everything is written in the chat. The first part is, so let's say that I am the attacker, and I know how to add admin accounts on the firewall. I can basically make Tommy open and add where basically I execute a code that adds the admin account. Yeah, in this case, it's not like this. It's like this. Let's say that this is not Tommy. This is the network. Sorry, I'm writing with my mouse. This is the network admin. Okay. Now the network administrator is logged in into his firewall management interface. Okay. Now with the same browser, he will then browse into Hackerland. Okay. Now, when this page will load, here I have my firewall, whatever. Okay, I can actually make relative links. I can basically have here add admin and so on. And basically what is going to happen is that the cookie will be used with the firewall here. And here we have everything related to the firewall. And this is the firewall actually. And a new account will be added to the firewall. So this works with most of the web applications. Is it clear? All right. Yes. Yeah, exactly. The prerequisite is that the network administrator has to browse this website. This can be done using a technique that is called phishing, by sending an email that has a link to this Hackerland web server, or I can hack a web application. I can hack, for example, I'm just saying Amazon. All right, I can put this in the comment section, and then this is going to be a cross-site scripting request forgery attack. Okay, so again, you can combine attacks together. You can combine a single injection to then perform a cross-site scripting attack. Okay, you just inject the code where it should be. Exactly. This only works if the user is logged in into the target application. Okay, it could be the firewall, it could be my bank. If the user is not logged in, so if the browser doesn't have session information about the target web application, this attack doesn't work. That's why it's A8. It's not A2. Okay, the damage is extensive, but it is hard to create and to use. Is everything clear? Cool. So the last attack is called unvalidated redirects and forwards. Basically, what you can do when you're browsing a web application is that you can append a different destination in the query, for example. And what will happen is that when the web application code will parse the URL, it will then say, all right, this is shop.com product.jsp, and then this is the product number, and destination hackerland.com. Okay, what is going to happen is that maybe this link was sent via email to Tommy. Again, this is a phishing attack. Okay, saying, hey, click here, we got new iPhones again at 200 euros. Click here, if you better be the first one because we only have 50 iPhones left. Okay, so click on this link, and then we're going to you can buy these iPhones. Now, shop.com might be a valid website. It could be Amazon.com. Okay. What we do actually is we append this additional destination parameter in the URL query, and what is happening is that the web application will then parse the query and say, okay, you want to see product 1 or 120. Oh, look at that, there is a redirection. So the web application will then say, sorry, you have to go to ackerland.com. So HTTP response 302, 301, redirection. Then the browser will say, okay, the content is not there. I am being redirected to where? Ackerland.com. So the request goes to ackerland.com, and then the response would then contain a malware, a virus, something that will exploit the browser, and so on. So the who is not validating the request is the web application, okay? Because the way that it's designed, it will not basically clear out this part, but it will actually tell the web browser to get content, to fetch content from an external server. Okay. Again, this is A10. Okay, this is the latest attack. This is the last attack of the list. All right. Sorry. Now I'm starting to perceive a little bit of fatigue. So this is basically what is going to happen with A10. Now, there are additional risks that are not covered by the OWASP top 10. For example, there is a type of attack that is called clickjacking. Now, clickjacking will allow you to create an overlay over a website, so the user is thinking that he is actually interacting with mybank.com, but in reality, he is interacting with Ackerland. And this is done in different ways. You can, for example, create an iframe on the page, and then the user will not see the iframe because it's transparent for him. So it's going to put, for example, username and password, and then this information is going to be sent to another server. So the user will then click submit, and then nothing happens, right? And then you would say you would try again. Okay, login successful, but in the meantime, username and password are sent to Ackerland. Other types of attacks, we have denial of service attacks. So we are going to basically try to crash a web server by using all the system resources. We can basically prevent that your web application is used by other users. Now, there are different types of denial of service attacks. The most commons are the Sloris, the Rudy, and the Slory DOS attack. Okay. Now, the type of attacks actually work by tricking either the web server using HTTP or the TCP connection. For example, in the Sloris attack, what is happening is that we are going to open an HTTP. We are going to create an HTTP request. Okay. And we're going to say, okay, this is, I want to get the default page. This is my host, request line. Then in the headers, we're going to write user agent, blah, blah, blah. Content type, blah, blah, blah. But then we're going to slow down and say accept, blah, blah. Then we're going to slow down and then say AB equals C. AB equals D. So we're going to post data, sorry, to actually send data to the web server very slowly. So our HTTP request never completes. Okay, it's still there, still continuing because we are still putting headers which are meaningless, and the web server is there waiting, saying, hey, okay, I got data. Then saying, what is happening? Oh, okay, I got data. Okay, so for one question, from one request, this is not a problem. For 1,000 requests, you're going to bring down a server. Okay, you just need one client. You don't need a distributed a botnet in order to create a distributed line of service. You just need one client, just one client that will start to open connections to the web server. Sorry, for some reasons my TV wants to shut down, and basically this will crash the web server. Another type of attack is the Rudy, or are you dead yet? This is again in HTTP requests, but in this case we're going to slowly post information. Okay, so we're going to put the HTTP, use the HTTP post method, and again this is a request that slowly send data in the request message body. All right, so instead of using the headers, we're going to use the body of the request message. Then we have the slow read DOS attack. This is in the response. Okay, so we're going to basically retrieve information from the web server, and when we are retrieving information, we are basically tampering with the TCP window sizes. So at the beginning we say our window size is this big and we can do 500 kilobits per second, okay, or 500 kilobytes per second. Let's say we have a broadband connection, a DSL connection. So we're actually downloading the content, and then after a while, this actually has shut it down. After a while, we are basically going to lower the TCP window size. Okay, so we're going to basically say, okay, now I can do 200. Now I can do 100. Now I can do 50. Now I can do 20. Now I can do 1. Okay, so we are going to lower the TCP window size and going to shrink it down, shrink it, until we are basically download the content at very, very slow data rates. Okay, what is happening is that the web server is still providing the content, but we'll never finish our to receive our response. Interestingly, the network firewalls do not catch this type of attacks. Even if you are tampering with TCP window sizes, they will not do anything. Okay, the WAF can actually protect you against this type of attacks. Last type of attack that we will say is information leakage. This is basically what we have seen before in our bad store. An exception, for example, is not handled correctly. Boom, you got information about the SQL server. Another example is Microsoft Exchange servers. They are vulnerable to user enumeration attacks. What does it mean? It means that you are typing in a right username, but a wrong password. What OWA will do is say, error, the username or the password is wrong. But if the username is correct, then it will stay in the input field. So potentially, you can continue to send a request to an Exchange server and then list all the valid mailboxes of the mail server. This is also true for Exchange 2013. Or you can send, again, another request to an Exchange server using the auto configuration protocol, saying, OK, I want to get the auto configuration protocol, even if you are on the internet. And then Exchange will say, OK, this is what you have to do, and this is my IP address, my private IP address. So this is information that Exchange, as a web application, is leaking. OK, and again, this is actually a problem, and we can prevent this type of things with the WAF. Now, before we will actually continue with web application firewalls, I will actually do the break. Okay, this is the long break. We're going to do 1 hour break, and then we will continue with the web application firewalls. So it's 12:35 for me. Okay, so in 1 hour, so at 13:35, I will start again. Okay, so again, I will wait a couple of minutes, but please try